Okay, go ahead and throw your name on here. It is currently second hour, but put your name and your hour on this, not my name in this hour. Okay, first things first, 6.7 notes. We are graphing quadratics today. This is a mistake. This should not say when a is greater than 1. I did that because it was like, oh, we have a number in front of x squared. Sometimes that number in front of x squared is negative, though. So instead of a is greater than 1, let's change this to say when a does not equal 1. I had already printed 120 of these, though, so I wasn't going to, like, white it out 120 times or reprint and waste paper. Okay, so a does not equal 1 today. So yeah, not yesterday, but 6.6, whenever you did 6.6, a was always 1. Our graphs always opened up, and they were kind of the same shape. Some of them were only those bottom 3 dots, so they looked little, but they were all about the same shape. Today, our graphs are going to be a lot taller and skinnier, because if we multiply by an a value, that stretches them out to be taller, and then some of them will be flipped up. First thing that we are going to do today is we are going to find our axis of symmetry. So that is the same thing that we did in 6.6. That's the same thing that we're going to start with. We're just doing axis of symmetry, though, not vertex. So moving down to our first example, let's do that. We have f of x equals 4x squared minus 16x plus 7. So my a value is 4. My b value is negative 16. And my c value is 7. My equation to find axis of symmetry is always the exact same. So I do x equals negative b over 2a. This is a problem where my b value is negative, so I'm going to end up with a double negative. So I've got the negative from the equation, and my b value is negative 16. So I've got negative 16 over, bottom of my fraction is 2a, so it's going to be 2 times 4. Okay. Any questions about that? Okay. That double negative flips to be positive, so I've got positive 16 over 2 times 4 is 8. And then 16 divided by 8 is 2. Okay. Any questions about finding the axis of symmetry? Okay. We know how to find the rest of our vertex from there, and we'll do it in a second, but we're going to do it within this table. So hold your horses on that. We will do that in a second. I want to show you how we're going to fill out the table. So we could graph that, or we could find the rest of our vertex and graph that. Then we could either factor or quadratic formula this to find zeros. But since our a value is not 1, these don't factor nearly as nicely, and a lot of times our zeros end up being decimals. So then we're over here graphing like 9 halves and then having to be like, okay, well, 9 halves, that's 4.5, and then put it in between 4 and 5, and it's kind of a mess. So instead of graphing the 5 points that are our vertex, our zeros, and our y-intercept and the mirrored y-intercept today, we're just going to take this point, the axis of symmetry. We know that's the middle. We're going to find that point, and then we're going to do 2 points to the right of it and 2 points to the left of it. So that is going to be step 2. We are going to create a table of values that includes the 2 integers less than the axis of symmetry, your axis of symmetry, and the 2 integers greater than the axis of symmetry. So down here on your table, we just found out that our axis of symmetry was 2. So put that in the middle right here. That is going to be our middle x value that we're going to evaluate for. Then, below that, put down 3 and 4, because those are the 2 numbers greater than 2. And then above that, because it makes sense to go from least to greatest, we're going to put 1 and 0. So we have to find the axis of symmetry to know where the middle of our table is going to be. And then instead of factoring, instead of plugging in and finding our y-intercept, instead of doing the quadratic formula and getting weird fractions, we're just going to plug in these 5 numbers. And that'll give us 5 points on our graph. We'll graph those 5 points, we'll sketch them together, and it'll be a parabola. So what it's going to look like now is we're going to go take our original equation, and I left space for us to do our work here, and we are going to plug in 0. So it's going to be 4 times 0 squared minus 16 times 0 plus 7. So I plugged in 0 everywhere there was an x. Okay, do we want to, let's fill out the whole table and then let's calculate, because I'm going to show you how you don't have to type it into your calculator 5 times. Okay, the next one, we've got 4 times 1 squared minus 16 times 1 plus 7. So if you write neatly, you'll be able to see everything's the same, you're just changing what x you plug in. Then I'm plugging in 2, my axis of symmetry. So 4 times 2 squared minus 16 times 2 plus 7. Do we understand what we're doing well enough that I don't have to narrate it? Okay, so then write down your 3 and your 4, plugging that in. Okay. Once you are done writing it down, go ahead and plug in the 0 one and then stop. So plug in the top one because it makes sense to do them in order, and then you can hit enter, but don't clear your calculator and don't start typing the next one. So plug in 4 times 0 squared minus 16 times 0 plus 7. What? Yeah, because we plugged in 0, so it's just 7. So everyone get to there and then look up so I know you're ready for me to show you how to save yourself so much time here in a second. Okay. If you are moving on and plugging in other numbers, please stop. If you have plugged in 0, set your calculator down and look up. Because you guys don't have to retype it 5 times for every problem. Okay, so we plugged in 0, we got 7, yeah? Okay, any questions about that? Okay, I would go ahead and write that down in my table. There are 2 ways to do this. I use the arrows, some people use second enter. So what you do now is you can hit second enter, and it puts what you just typed in back on a new row. Then use your arrow keys to scroll over, hover over the 0, replace it with a 1, hover over the other 0, replace it with a 1. Hit enter, you've done another row, and you've only had to type 2 things instead of having to type the whole row. Okay, so I replaced them with 1s. I got -5. So you can hit second enter to get back. The other thing that you can do, and what I prefer to do, it just makes more sense to me, is you can use your up arrows. So up arrow, and you can go select and then hit enter, and it puts it back in. I didn't know about the second arrow, the second enter option until yesterday. So you can replace it with 2s now. So you replace with 2s. We hit enter, we get -9. Okay, any questions about what I'm doing? Okay, go ahead and plug in 3 and 4 then. So try it out. Don't just sit there and write down what I'm writing down and not touch your calculator, because if you can't calculate it, you're not going to be able to do your assignment. So I could do it. What did you guys get for 3? -5. Okay. What did you guys get for 4? Okay. Do we see any patterns? So look at the answers we got. What do you guys notice? So 1 and 3 have the same value, and 0 and 4 have the same value. So when we graph it, remember how yesterday, not yesterday, 6.6 is whenever we did that, our quick write was, what does it look like to be symmetrical? It's because our graphs need to be symmetrical, okay? If I were you, I would not just do the first 3 and then assume you were right and assume you were right. I would do the first 3 and then do the last 2 and then use it to check yourself and make sure that you didn't mess something up. Because it's really easy when you guys get going fast to forget to replace both and accidentally only replace one. Or like delete something else or like change something to a negative. All right, we're going to go ahead and graph these now. So these are ordered pairs. So this is my X value. This was just me showing my work. This is my Y value. So I'm graphing 0, 7. So I go over 0, up 7. This is 1, -5. So I go right 1, down 5. This is 2, -9. So I go right 2, down 9. This is 3, -5. So I go right 3, down 5. And this is 4, 7. So I go right 4, up 7. Okay. We are going to connect these. Reminder, connect them into a U, not a V. So try to curve it out a little bit. Do your best. Because these would go up, up, up really fast. Because if I were to plug in 5, and the reason why we're only doing 5 values is 5 is all that's ever going to fit on the graph. If I were to plug in one more value, I would get 27. So like literally 5 would be 27 would be like all the way up here. Okay? So they get real steep real fast because they have those higher A values. Any questions at the moment? Okay. Flip this over. We've got one more to do. What is my A value here? -3. What's my B value? -6. What's my C value? 5. Okay, so I am going to do X equals -B over 2A. This one has another negative on the B. So it's negative from the formula and -6 from my B value. So -6 over my A value is 2 times -3. Well, my A value is -3. The 2 is part of the equation. So I end up with -6 on top, so that's +6. And then 2 times -3 on bottom, so that's -6. Lots of messy negatives in this one, which is why we put it in notes so we could see this. So any questions about the negatives right now? Okay, you have a question? Or you stretch it? Okay, so then 6 divided by -6 is -1. So our axis of symmetry is X equals -1. The other thing is having the correct axis of symmetry is going to be important to having the correct 5 numbers on your table. So if you make your table and you don't get that pattern where the first and the last number and the second and the fourth number are the same, that means your axis of symmetry might have been wrong. You might have chosen to use the 5 wrong numbers. And if that happens, you could erase all of the x values you plugged in and replace those instead of having to erase all of your work, because the equation is going to stay the same. It'll just be the x values inside that change. All right, we'll put this -1 here. It goes in the middle. What are the 2 values greater than -1? 0 and 1. And then the 2 values less than -1 are going to be -2 and -3. So this one, some of the numbers we plug in are going to be negative and some are going to be positive. So I will show you in the calculator here in a second how to delete that negative. The answer is you use the delete button. Okay, so let's put down our work. We've got -3 times -3 squared minus 6 times -3 plus 5. -3 times -2 squared minus 6 times -2 plus 5. I'm going to stop narrating that. Any questions about setting up and writing down our work? Okay, I'm going to plug in those first 3 then. So -3 times -3 squared minus 6 times -3 plus 5. I get -4 for my first one. Did other people get -4? Okay, cool, because like I'm just as susceptible of making mistakes as you guys are. Then I'm going to scroll second enter, get it back, replace with the -2. So keep the negative and put in the 2. I get 5. Did other people get 5? Yes, no, maybe so. Hope so. And then I'm going to do the -1. So I'm replacing my -2s with -1s. And I get 8. All right. Please pause typing for a moment and look up. Now that I am typing in 0 instead of -1, so -1 took up 2 digits, where 0 and 1, I only need 1. So when I scroll over, I'm going to delete the negative. So I'm going to hover over the negative and hit delete on it, and then replace the 1 with a 0. Hover over the negative and delete it, replace the 1 with a 0. So if you have negatives and positives, at some point you'll have to delete that negative when you move from the negative side to the positive side. Hit enter, I get 5, which makes sense because that's my y-intercept. And then the last one, I'm going to plug in 1. And I'm going to get -4. Okay. Any questions about filling out the table? All right, which way is this graph going to open? Down. Okay, somebody else. Why is it opening down? How do we know it's going to open down? Yeah, because A is negative. Cool. All right, so we are going to graph these now. -3, -4, so left 3, down 4. Boop. -2, -5, or -2, positive 5. So left 2, up 5. Yep. -1, 8. So left 1, up 8. 0, 5. So over 0, up 5. And then 1, -4. All right. When I connect those, I connect them into a U. ladies and gentlefolks, that's a wrap on these notes. Go ahead and glue these in. And then I want to show you something on your assignment while I'm still recording so that the kids tomorrow in my odd classes that are watching this video can get their instructions for their assignment. Glue your notes in and then look up. All right, so this is what your 6.7 assignment looks like. First of all, if it matters to you and you want to change this, you can change it to say A does not equal 1. Then there are 6 problems like what we did in notes. So you're going to do that 6 times. Once you guys get good at the calculator, it'll go pretty quick, okay? So write them out, calculate them, graph them, make sure they line up. Those are your 6 problems to get full credit on this assignment. So 1, 2, 3, 4, 5, 6. We did have to make the assignment a whole page folded in half because there is no physical way you would have to write, in order to fit these tables, you would have had to write so small and then your graphs would be like tiny if we made them any smaller. Okay, on the back side of this assignment is a bonus question that you can get 2 points of extra credit for. I would strongly recommend doing this if you get done and you have time. This is something that we have had students do in the past, something that you have learned all the pieces of and you will do in Algebra 2. We just don't have time this year to make everyone do it. And right now we're not at the point with our factoring and quadratic formula skills where we're going to make everyone do it. But if you are done with this assignment and you're done with all your other assignments, you should do this. At least make an attempt. What you're going to do is you're essentially going to graph one of these problems where A does not equal 1 in the same way that you graphed in 6.6. So you'll find your axis, symmetry, and vertex, like we did in 6.6. You know how to do that. Then you will find your zeros. I put this hint here. This is what's different. You have to use factoring or the quadratic formula to find your zeros. Your zeros will be fractions. That is okay. Once you get your fraction answer, let's say you get 7/3. I don't think that's it. You can turn that into a decimal on this assignment only to know that you would graph that at 2.33. Write down the 7/3 here. 7/3 is not the answer. So write down the fraction, but then when you're trying to graph it and figure out where it goes, because like, I don't know off the top, I guess I know that 7/3 is in between 2 and 3, but you might want to turn it into a decimal. And then y-intercept happens the same way it did in 6.6, and then you're going to graph it. So this is us doing one problem where A is greater than 1 and doing it by hand. Any questions at the moment for the good of the cause?